Right, so remember when I said Python was good at calculations? Well, let me give it a tough calculation to perform to see how it gets on. So Python, 1 plus 1 is the same as 2, correct? Okay, good, I'm glad this said true. How about 1.1 plus 1? Does this equal 2.1? Okay, yes, also true, good stuff. Now does 1.1 plus 2.2 equal 3.3? False. Okay, I'm pretty sure Python is making a mistake here, so what's going on? Well, it turns out that floating point numbers are implemented in computer hardware as binary fractions, as the computer only understands zeros and ones. And it turns out that the decimal fraction 0.1 will result in an infinitely long binary fraction that looks something like this. And our computer will only store a finite number of it. Now this will only approximate therefore to 0.1, but will never be equal. Hence it's the limitation of our computer hardware and not an error in Python. So if I actually perform the calculation 1.1 plus 2.2, you can see we get 3.3 with a bunch of zeros and then 3 on the end. Now due to this reason, most of the decimal fractions that we know cannot be accurately stored in our computer. So as an example, we cannot represent the fraction 1 over 3 as a decimal number. This will give us 0.333 recurring, which we know is infinitely long, and we can only approximate it. Now to overcome this approximation issue, we can use the decimal module that comes with Python, which helps us work with high levels of precision. So while floating point numbers will enable us to have precision up to 15 decimal places, the decimal module allows the user to set the precision. So let's see how this can benefit us. Now for this part of the video, feel free to sit back and just observe what's happening. When it comes to importing modules and packages and how we can access different functions from this will be covered in detail later in the course. I just want you to see how the decimal module can help. So if we first of all import the decimal module, which now means we can utilize its functionality, I will first of all print 0.1 to the screen. I will then print 0.1, but I will access some functionality from the decimal module called decimal, in which I will pass in 0.1. Now when I run this code cell, you can see that we print 0.1, and then we print 0.1 with lots of zeros, and then 555, 111, and so on. So the decimal module is used when we want to carry out decimal calculations to a high precision, based on the value that's stored on our computer. Now if I were to ask you what's more accurate, 10.5 or 10.50, hopefully you'd tell me it's 10.50 because it has 2 significant decimal places compared to the one of 10.5. So working with more decimal places gives us higher precision. Now if I just import that same decimal function, but this time alias it as the letter D, which will just make the subsequent code more simple to type, if I now perform the calculation of 1.1 plus 2.2 and compare this to 3.3, this time passing it into that decimal function that comes from the decimal module, you can now see that we return true because we're working with a high precision of decimal figures that's stored on our machine. So you now may be thinking, well, if this is more accurate, why don't we just use the decimal module every time instead of using floats? Well, the main reason is efficiency. Now, floating point operations are carried out so much faster than decimal operations, and precision up to 15 decimal places is usually good enough for the granularity that we need. So when should we use the decimal module instead of floats? Well, we generally use decimal when we need high levels of precision. So for example, if we're making a financial application that needs exact decimal representation, then the decimal module would be a good option. We would also use the decimal module if we want to control the level of precision that's required. Now hopefully this highlights the nuance when working with floating point numbers and provides some clarity on how we can be more accurate with numbers when using Python. we have to be mindful that storing infinite numbers on a computer is not possible in finite memory. So the computer may perform some strange things if you're not aware of this nuance. If granularity and precision is what you need, the decimal module can certainly help you with this.